So given the sequence 210, 50, 250, complete parts A through C below, first of all, it says describe what kind of sequence it is. The two types of sequence we have that we've been dealing with are arithmetic and geometric. In an arithmetic sequence, we would be able to identify it because our terms would have a common difference. In other words, we would be adding by the same value each time. If I look at this sequence, the first jump from a 2 to the 10 is adding 8, and then a jump by addition to the next term is plus 40. So I quickly see, you know what, this is not a common difference, right? I'm not adding the same thing each time. So if it's anything, it would be geometric. So let's consider geometric. If I start at the number 2 and multiply by 5, right? 2 times 5, it is 10. And then 10, right, times 5 does give me 50, and 50 times 5 does give me 250. So it is a geometric sequence. So I'll just write geometric. And while we're here, let's note that the common ratio or the common multiple, actually they call it the generator too, multiplier, is times 5. So every single time we jump forward, we're multiplying times 5. The other thing is that we need to often know the 0th term, for both arithmetic and geometric sequences. You can see if we move forward by multiplying by 5, if I want to know what the 0th term is, the term that occurs before this first term, I can get back to it by dividing by 5 instead. So if I take 2 divided by 5, right, here is my 0 term. And that might be necessary or useful for us. So the first term is 2, 2 times 5 is 10, and 10 times 5 is 50, etc. But the 0 term in that sequence would be 2/5. The next thing it says is describe the shape of this graph. These numbers get large quickly, but I can definitely graph the first 3 points. I set up a little graph here. So at 1, right, we were at the number 2. And on the second term, when I take 2 and multiply by 5, I jump to 10. And then when I take the next one, 10 and multiply by 5, I jump all the way to 50, right? 3 times, the third term is 10 times 5, which is 50. And we know that, in a sequence, our domain is limited to just these integers, right? The first term, the second term, the third term, the fourth term, etc. So we're not looking at the in-between points. But if I want to describe the look of this graph, I might just kind of sketch it kind of roughly, right? And when I look at this, I say to myself, well, it's definitely not a line, right? It's a curve. And I think that's all I'll use for the description. I'll just say it says describe the shape of this graph. This is geometric. It is definitely a curve. And then the final question is write an explicit equation for the sequence. So I'll use function notation. I'll call this A. And I'll say the value of this sequence for A of n. And in general, for a geometric sequence, it's always the value of the 0 term. Right? And we multiply that by our common ratio. Two m's, common ratio. And that common ratio is also the multiplier, right? It could be a fraction, less than 1, but it's what we continue to multiply to move forward. And then we raise that common ratio to a power of our variable. And here our variable is n for this function, right? It's A of n. So it's to the nth power. So for this geometric sequence, right, if I was going to write down this particular one, I'll use the name A. So A is a function of n, says give me an n, and I'll tell you what the value is at that point. Well, the 0 term we've already decided was 2/5. Let's go back by dividing by 5 and get 2/5 is the 0 term. Each time we move forward, we are multiplying by the number 5, and our exponent is the number n. So it's A of n equals 2/5 times 5 raised to the nth power. And you can pick any value you want and plug it in there, and it'll tell you the correct one. So for example, if I was to check this with this calculator, if I want to know what the fourth term is, right, 1, 2, 3, 4, I can see the fourth term is 250, but just as a check, I'm going to take 2/5, and I'll use parentheses actually. So open parentheses, 2 divided by 5, close the parentheses. And then I'm going to multiply that by open parentheses. I'll put 5 in there. And I'll just raise that to the power of 4. And you can see as soon as I do that, it tells me the fourth term is 250. So this explicit formula right here does a very good job of telling me what the value of this sequence is for any spot I wish, right? Just tell me the spot, the nth, the 10th, the 100th spot. Plug that number into this expression on this side, and that'll tell you what the sequence is at that point.